That's better than a Asymptotes.
All right, guys. Anybody need a copy of the practice test while I'm thinking about it? Oh, answer keys coming someday. Today.
Yeah.
You need one? No.
I was too worried about that text in there.
Is that everybody? Everybody has one.
I do.
That's all that matters, right? I do.
Good. All right, guys. So there's a couple things I want to remind you about for section 4.5. What is the idea of? Because I might use this phrase, and I've already used this phrase, but I might actually put it down on your test. The idea of end behavior. So everything's easier when you have polynomials. So don't tell me about, in respect to polynomials, what it means. Because there's shortcuts with polynomials. What is it in general? What does it mean? Holy crap. Let me see, who knows? Raise your hand. Anybody? Yes, ma'am.
Do the ends go up or down, and are they the same or are they different?
I like it. So it's all about, obviously, end behavior is all about the ends. Now, describe the ends more technically for me. What do you mean by the ends? When who to what goes to where? When X goes to or I like it. So that's what end behavior really is. So when I have easy example, when I have a function like this, what would its end behavior be? What would the highest power be? What would the degree of this be?
7.
No. You can't tell me what the degree of this polynomial is by just looking at each power separately because they haven't been multiplied yet. If I did, well, please, dear God, nobody hear me say multiply. If you did multiply this, you would have what is the highest power? 12th power. Right? In fact, do you guys remember, I don't know if you guys remember, I just taught my Math 90 students this. Can we tell me the degree of this term? No?
1.
Nope. 8th degree. I love it. It's the 8th degree because you add the powers of all the variables. And the reason that is because this is going to grow like this if x and y were allowed to change at the same rate. They would both grow the same. If I made y equal to x, isn't that what that is? Does anybody remember the idea of degree? Maybe this is a long time ago, but they actually has. And I keep saying degree, but if I have multiple variables, so what am I saying it applies here? I'm adding the powers, right, of this variable and that variable, so it's the 12th degree, so then it would be touchdown, right? Because the limit as x goes to infinity of this would be infinity, and the limit as x goes to infinity would also be infinity. All right. So we got shortcuts for polynomials. We need to all be able to do this. And you know I'm going to give you a problem a lot like the one you got on this quiz, because I need one problem that's relatively nice, the intercepts are nice, everything's kind of nice. So that's polynomial. Polynomials are nice. So let me try another one. What would the end behavior on this here be?
10.
What's the degree?
9.
9th degree. I like it. So what's the end behavior going to be?
1.
Yeah, somebody took my pre-calc. Huh?
Like this.
All right. Yeah. All I can think of is you're a little teapot. Right? I'm a little teapot. Yeah. So that's what in my pre-calc class we call this cubish. Right. So any odd degree is going to look cubish. Another instructor calls this the giraffe graph. I don't know if you guys know this instructor, Corey. And I always joke Corey because this poor giraffe, one of his legs, he's about to topple over. It's so horrible. I don't know. So that's, if you like toppling legless giraffes, you can call it the giraffe graph.
So for example, one, they're both pointing up.
Yeah, so this one will be like this. I like it. Cool. This one's going to be like that. And what happens if I put a negative in front? Okay, good. So that's one part of what's going to happen to you in section 4-5 homework and on this test. Good. Right. So I'm going to ask you, like, my first question, or one of the first questions may be, what's the end behavior of this? So if I give you a function instead like this, if your function was this, how would you do the end behavior? Oh shit, what's the degree of that? Ain't no such thing. It ain't got no degree. Never did go to college. Sorry, that's, you know, oh, too good. Why, thank God I don't make my living off of comedy or something.
That's a good one.
Oh, yeah. That's the best one yet, Joe. That one joke might get you enough for ramen noodles.
I'm funny.
Be my life, ramen noodles, cheesy boost.
Oh my god, I needed this at your house.
No, that would be my life. That was my life way back when. Alright, so how do I look at the end behavior? What did we just say earlier? What's the end behavior really technically built on? No, that's not what it's technically, that's a shortcut for polynomials. What's it built on? The limit. Yeah, so what's the limit? Here's the easy one. So the limit of x goes to positive infinity of this. There's no question that that's what? Infinity. It's like infinity times infinity. It's like super infinity. Right? Infinity. I like it. There's no super infinity, sorry. We'll draw a little cape on it. Now somebody's going to do that. I'll appreciate that if you do. What about limit of x goes to negative infinity? Things gets a little bit weirder. Why do you say 0? What's x doing? Going to negative infinity. And what's e to the x doing? Going to 0. I like it. Negative infinity times 0 is officially
0.
No. That is an indeterminate form. Oh shit, there's a reason we learned that? Besides just making it easier to do limits? Yeah, anytime you have a limit, and it's in an indeterminate form. Now this one is not a difficult indeterminate form. Which one do you think always moves faster? X or e to the x? E to the x, right? It grows really fast and it shrinks really fast. It's just fast. Right? X. Right? So it should win. This guy should win. So the whole thing should go to infinity. But how do I show that technically? How do I really prove it? What's wrong with the form it's in? Is it in the form that we can use L'Hopital's for? No. Oh shit, there's a little review. How does he work that in? This is a multiplication. L'Hopital's has to use what? It has to be in what form?
0.
It has to be in a ratio. Thank you. There it is. Right? And sure enough, which one do you want to bring down? And if I bring it down, what happens? I really want you guys to get used to this. If it's indeterminate form, that is certainly an indeterminate form because it depends on which one's going to 0 or infinity faster. That's the one that's going to win. That's what the whole thing's going to do. I don't know. I got to write it as a ratio, though, to use the hospital man. Right? So to me, I'd rather do this. It doesn't really matter, to be honest with you. Because exponentials are easy to take derivative of no matter what's going on. Right? You guys with me? Is that still the same thing?
Mm-hmm.
And then what can I do with this now officially? Because what form is this in now? Negative infinity over 0. No. Infinity. Yeah. Negative infinity over infinity. We don't know what that is. That's indeterminate. It depends on which one's growing. But I changed the form of it so L'Hopital's can attack it. L'Hopital's only says something about ratios of rates. So I have to start with a ratio to use L'Hopital's. So now if I apply, what is L'Hopital's? What does it mean? What happens when I apply it? Cool. I'll do the top.
Yeah. Minus negative x.
Yeah, it'll be negative x and then chain rule, negative. So then I get 1 over So remember, what was it doing? What was this doing? Going to infinity, right? So you get 1 over infinity. Well, negative infinity. So it doesn't matter. 1 over any kind of infinity is going to 0. And why does it make sense? Because this was going to 0, right? Sorry, this one. This was going to 0 faster than this is going to negative infinity, so it should pull the whole thing to 0. We kind of knew that going in, that this guy's going faster. And I love the fact that it makes sense to say that, right? A lot of you guys thought about it that way. Maybe didn't even realize you were doing that. And that's why L'Hopital's make so much freaking sense. It looks directly at the rates. How quickly are they going if it's all based on who wins? It only makes sense. Okay. So some of the functions they give you, it's not going to be, polynomials easy. There's shortcuts for polynomials. They're easy. End behavior or asymptotes, horizontal asymptotes, right? That's really what end behavior is. For some funky function, then you have to go back to fundamentals. You have to go back to what it's built on, the limit. Let x get really big, both directions. All right, how are we doing so far? So just like I added in finding the intercepts on top of the calculus, right? The calculus part is first derivative, critical numbers, increasing, decreasing, max, min. Second derivative, critical numbers, concave up, down, inflection points. That's the calculus part. On top of that, I can add intercepts, asymptotes, domain, range, all that kind of shit. Right? I like it. And of course, the domain for this guy is... Any x's you're not allowed to put in here? I can put whatever the hell I want to in there, right? Alright, so it's all real numbers. There's no restriction on there, so it's all real numbers. If there's nothing I can say that would restrict it. Does that make sense? There's no radicals, there's no variables on the bottom. There's nothing that would restrict what I could put in there. So my domain would be all real numbers. Okay. I think there's one more thing. Oh, that's right. Somebody said something a second ago about something related to this. Let me see if this jogs your memory here a little bit. That's gross. That's yummy. You do this, let's call it ethics. So, somebody tell me something pre-calculusy about this thing. Like, how would you find the intercepts? How would you find the x-intercepts? You don't. You just... It's mythical, John. It's said to exist. Making a movie about it. No. X-intercepts. If I want to find the x-intercepts, for example. One thing we could do is find the x-intercepts. How do I find the x-intercepts? Make this equal 0. So when is this equal to 0? When's a fraction equal 0? When the top is 0. I like it. So if you factor the top, you can see what your x-intercepts are. Does that sound familiar? How do you make a fraction 0? You make the top 0. There's no other way to make a fraction 0. If the top is not 0, it ain't 0. So to make it 0, you make the top 0. Bam! You guys with me?
Yes.
I like it too. So what would that be? How do I factor this?
X minus 1.
Yeah, one of each. 1x and 1.
And then x squared.
2 of each.
Minus 2x.
No. Product.
Plus x.
And it's the cleanup dude from Pulp Fiction, right? Did I tell you guys about that?
Oh,
Yeah, there you go. Cleanup dude, right? It's a little warning I'm doing right now to remind you about cubes, because you know I'm going to put a freaking cubes on here. You know it's going to happen. You got to know how to factor at calculus level. You just have to. So where are my x-intercepts? This tells me x is 1. Does that have any real answers?
Yes. Oh no.
Nope. In fact, what's really cool, I don't think you guys do this in pre-calculus. Stay with me for a second. Do you guys remember plotting complex numbers?
Yeah.
Do you remember this kind of thing? Remember that?
Yeah.
3 plus 5i, 3 plus 5i, and you have angles and shit like that. You guys did that stuff in pre-calc. So when you have an answer to a cubic, what's really cool is they're going to be equally spaced by degrees in the complex plane. So if you take 360 degrees divided by 3, what do you get? 360 is 120. So they're going to be 120 degrees apart. So there's going to be two more answers back here. 120, 120, 120. Well, not like that, but that's close enough. Bigger. So my two other answers are going to be complex. There's not going to be any other real x-intercepts. That's unbelievably interesting if you let it be. You actually have to know. No, you just do the discriminant here and see it's going to be negative. So screw it. I'm only dealing with real stuff here now. Right? We're not, thank God, we're not plotting complex numbers. Although that would be really neat. It would be freaking hard. So we're not doing that. I like it. So the x-intercept here would be 1. What about the y-intercept? Is there a y-intercept? How do you find the y-intercept? Make x0. What happens when you make x0?
Negative 1 over negative.
Negative 1 over... Oh shit. Are there any y-intercepts?
Nope.
No. No y-intercepts. Oh shit. Alright, what else can you tell me about this thing? Where's the asymptotes? What kind of asymptotes do we know about?
Horizontal.
Alright, how do you find horizontal asymptote? Of course, you want to start with a weirder one. Do you remember the 3 situations? This is a simple, this is just a polynomial over a polynomial. Everybody with me? So it's a little bit harder than a polynomial times a polynomial. I guarantee you that. That's fine. We understand that. But do you remember the 3 situations here? It's all about, in fact, you could use L'Hopital's. Because if you let x go really big, what form is it in? Let x get really big. Infinity over infinity. I like it. You guys understand? You could use L'Hopital's, so why would you? Does anybody remember the what am I in? What situation am I in? Who's going to win, the top or the bottom?
Top.
Top. So it's going to go to that one. All right. So if it was this, it would go to 1. The ratio of the coefficients, because they go to infinity at equal rates. So therefore, it's all about, well, is one double of the other one? That's all that matters. One isn't going exponentially faster or something. They're just going at about the same rate, right? So then it's the ratio of the coefficients. If the bottom was bigger, it would go to 0, because now I'm dividing some poor little thing by something that's growing much faster. So it's like killing it, it goes to 0. Right? Very violent math. Here, the top degree is higher, so this is going to go to infinity. There is no horizontal asymptote, but there is. It's either called slant or oblique, if you want to be really technical, right? Does anybody remember that idea? Slant asymptotes?
Remember the words.
I like it. That's somewhere to start. And how do you find that? Then you would long divide. Now the limit I know is infinity. So, I mean, if I did L'Hopital's rule, I get infinity. What am I doing now? Now I really want you to understand. When x gets really big, then this is going to go to infinity. But how is it going to go to infinity? Is it going to go to infinity following a parabola? Is it going to go to infinity following this line? Is it going to go to infinity following this line? How is it going to go to infinity? How many ways is there? A lot. Natural log goes to infinity very slowly. Oh yeah. Right? Whereas e to the x goes to infinity, just get it over with. Shit. Oh yeah. Shit. Right? You guys understand what I'm saying?
Yeah.
So there are infinite, obviously, number of ways to go to infinity. I want to know exactly how is he going to infinity. Infinity is not specific enough. How is he getting there? And you're all like, we don't care. Okay. So I don't know if you remember what you have to do. Not with square. Now you could do a synthetic. It gets really difficult to handle the remainders if you divide it by both factors. There's actually a way. Oh, because this. Little placeholders, right? Placeholders. So then, just to do this real quick, x cubed, plus 2x squared. Change the sign, negative 2x squared. And then it would be minus 2. And then who cares about the rest? Whatever this remainder is, it's going to be over, I really want this to make sense, plus, who gives a shit, over x squared plus 2x. This piece is always going to go to 0. Because you cut it down to have a power lower on the top. In fact, I don't know if you guys understand. So if I did this, negative 2x squared minus 4x, yeah, change the signs, so I get 4x minus 1, so I get plus 4x minus 1 over that. What's that limit? As x goes to infinity, 0, always. The remainder always goes to 0, always. So then, as x goes to infinity, what does my function look like? It looks more and more like x minus 2. So then I've got, here's x minus 2. So as x goes to infinity, it's got to approach that line. Just like it would any asymptote, it's got to approach the line. Does that sound familiar at all to anybody?
Yes.
So this is why pre-calculus exists. This is why pre-calculus, why I call it graphing hell. That should be relatively easy now, so I can just load calculus on top of that. Right? If this is a problem,
So okay. Just do like a missing point on the y-axis, and would it become negative? Because there's no y-intercept.
Oh, so remember now, that means there's going to be a vertical asymptote on the y-axis, right? In fact, how do I find the vertical asymptotes? Where do they come from? Well, somebody tell me in English, what's a vertical asymptote? And they'll say, asymptote, that is vertical. What's it mean for the function for there to be a vertical asymptote somewhere?
What y approaches, but never reaches.
Yeah, so either you have an open circle there, or it goes like this, right? Or something like that, or something, right? That's what it really means. So vertical asymptotes are not just suggestions. They are, you cannot go here. Horizontal asymptotes are, oh yeah, sometimes you go. Just eventually get really close to this. So horizontal asymptotes are suggestions. The bigger x is, the more important it is. Vertical is, oh, no freaking way. You can't go here. So yeah, what are the vertical asymptotes going to be?
0.
X equals 0.
Minus 2.
Negative 2. Well, just factor the bottom, you can see what x can't be. So the vertical asymptotes come from the domain, the restrictions on the domain. So polynomials, rational expressions which are just divided polynomials, those should be easy. We have shortcuts. We don't have to actually apply the limit. We have shortcuts, right? Some other function, I give you some trig function with exponentials, and who else knows what Jeff's going to do to you? Oh shit. If I give you some function and I ask you what's the end behavior, you attack it with limits. And you got L'Hopital's now. L'Hopital's is a stupid powerful tool. Makes a lot of limits so much easier. Look back at some of the limits we did back in chapter 2. You're like, oh man, those are easy as hell now. Like it. Not because we're mean. You have to know derivatives before you do L'Hopital rule, and you have to know limits before you can learn derivatives. Oh shit. Okay. Alright, let me give you guys the answer key, and I'll open it up to whatever you guys want to do. If you want to do an example problem, or if you have questions on some idea.
So then the test is 4 and 4.5.
Yeah, 4.1 to 4.5. Yeah.
So are we going to get back tomorrow? We have to have it by.
Yeah, so tomorrow I will have the quizzes graded, and the corrections, any corrections you want to do, are due the next day. So we got some time now. Whatever you guys want to look at, let me know. Just wanted to check out the answer key. All right. So, man, a really good question. If you'll notice on 1A, part 6, where I asked you to find the intercepts, do you see what I put next to the x-intercept? Yeah, good. All right. So the book kind of backs this up too. If the x-intercepts are impossible to find by hand, just passing by. So what did I do instead? Look at the graph. What did I do instead? How did I figure out about where my intercepts were? I don't know, Jeff, man, you do all kind of weird shit. You know more math. Yeah, I just did some points. I said, I know the inflection point is really close to the x-axis, so I know the x-intercept is going to be really close to that too. Is that cool? Because the y-intercept's up here, and and then the inflection point was right below the x-axis, so it had to have a little. So I didn't worry about that one. That was fine. I didn't have to be perfect on that. And I knew 3 was a minimum, and I knew it turned and went up. So I was just like, okay, if I could see where it is at 4, if it's at positive at 4, then I know the x-intercept's between them. If not, I'll plug a 5 in and see where the hell this thing is. I can approximate where intercepts are by throwing some points in. Now, I'm going to say this on the test. The most points that'll allow you to plug in is 2. Because otherwise you just start plugging like 8 points in, and then you're not using calculus to plot it. You're just connecting the dots. There you go. No. Points are just supposed to help you when there's something you can't get easier, like intercepts. They replace intercepts then. I don't know the intercepts, let me get some other points. Right, some anchor points.
-1 and 4?
Yeah. Yep. 4 is good. -1, I don't remember why exactly I did that, just to see how quickly it's going up back there, I guess. You didn't have to use that one, but 4 is what helped me. The x-intercept somewhere between 3 and 4. Now, obviously, you can find out exactly where it is with your graphing calculator, but your graphing calculator is not what needs to pass this course. You are. The human. Right? Always. Oh, yes. When I teach stats, I always have, the last teacher told me, just do this button, like your calculator will pass the class. You'll take it again. Dadgummit. We're the humans. We created this shit. Don't relegate it to the calculator. Anyway, sorry. Blah, 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 blah. Let me see. What else is kind of weird on here? Did I get it all on here? Did I do number 4? Yes, thank God. Oh, yeah. 3A and then 3B is down there. I skipped poor little 3B. Poor little 3B. Alright. Well, there's 3A and then 4 and then 3B.
You skipped it, so it's up the bottom.
Yeah, it's towards the bottom. Yeah. It's nowhere near as bad as some of you guys with your homework. Number 7, number 15, number 32, number 12. Oh, shit. So maybe give me a little map. It's up front. Was the cover sheet? A little map. Something. Some of you guys have to help me out. Okay. You want to do an example from 4-5, or do you? Anybody have questions from homework? I didn't really take questions from homework. So 4-5, you want to do one from 4-5? No. Yes? Okay. Yeah. Oh yeah. Let's see if we can power through this. What's really interesting about this function is, if that -1 wasn't there, this looks like it should be 1 or -1, right? Because square root of x squared is absolute value of x. You guys see what I'm saying? So it looks like it wants to be close to 1 or -1 somehow. So this function, now see what it looks like at the end. We'll see how close it is to being that. If that minus wasn't there, that's what it would be. It would reduce down to 1 to -1. Easy. Too bad I put that in there. How the hell do I find the domain? What part of this function has a problem?
Anything?
There's something on the bottom, and then on top of that, the thing on the bottom is in a radical. Holy shit. So normally, what can't happen, what must happen for something inside of a radical? Normally has to be at least 0. because that's the smallest thing I can take square root of and still stay real, right? But now since it's on the bottom, and it can't be equal to 0, so it's therefore x squared minus 1 has to be strictly greater than 0. If it was just a radical, it can handle 0, but it's on the bottom, it can't handle 0. Oh shit. Now here's where we have trouble. Some of us answer this in multiple ways. I'm going to show you real quick. Well, yeah, time. I'm going to show you the way to do it algebraically, and then I'll show you a better way to do it. So algebraically, the mistake people make is after this point. Thankfully, most people can factor that, but then you can't say that greater than 0, that greater than 0, because that's only one way to have that happen. What if they were both negative? Wouldn't the product be positive then? So there starts to get to be too many cases to keep track of. I don't want to do it that way. Shit, no. So what do I do instead? I do something that seems very familiar. This should have been the first kind of problem you did this on, back in pre-calc. So 1 and -1 are my zeros, right?
Yeah.
I'm looking, what's this really asking me? Where is the result positive? So then I graph the results, not the outputs themselves, but just is it positive or negative? So at 0, this is
Positive times negative.
good, positive times negative, so it's negative. And the multiplicity makes it change on either side, right? Or if you don't like multiplicity, you can just plug a 2 in, positive, positive. Plug a -2 in, negative, negative. You guys still with me a little bit?
Yes.
All right, so then what's the answer then?